Why do the carbonates, nitrates and hydroxides of group 2 elements decompose to their corresponding oxides? Let us look at the thermal decomposition of magnesium carbonate. Click on MgCO3 and then MgO. The oxide ion is smaller than the carbonate ion, which has a higher lattice energy, magnesium carbonate or magnesium oxide. Answer: magnesium oxide. Thus, the larger carbonate ion decomposes on heating to form the smaller oxide ion, as the metal oxide is more stable. The oxide ion is also smaller than the nitrate and hydroxide ions. Thus, the group 2 oxides are also more stable than their corresponding nitrates and hydroxides. Click on each of the arrows in turn to heat the 3 different carbonates shown. Observe the lime water in the 3 different test tubes. Note the temperature required for the thermal decomposition to occur. What is the order of thermal stability of the carbonates? Click the Answer button to see if you are correct. To find out why the thermal stability of group 2 carbonates increases down the group, click the Next button. The decomposition of group 2 carbonates, nitrates and hydroxides depends on the polarizing power of the cation. Click on the Play button to view how the decomposition of the carbonate ion takes place. The electron cloud of the large carbonate ion is being polarized by the cation, which has a high charge density. The carbon-oxygen bond is weakened, and the carbonate ion can now be easily decomposed to the smaller oxide ion. Click on the Play button again. How does the polarizing power of the group 2 cations change down the group? Click on M2+ to check your answer. The size of the cations increases down the group. The charge density and hence the polarizing power of the cations decreases. As a result, the cations are less able to distort the anions and cause their covalent bonds to break. Summary: the nitrates, carbonates and hydroxides of group 2 elements can be decomposed to the corresponding oxides, as the oxides have lower lattice energies and are thus more stable. The thermal stability of the nitrates, carbonates, and hydroxides of group 2 elements increases down the group. The charge density and hence the polarizing power of the group 2 cations decreases down the group.